In this part, we are going to talk about these points. Point number one in physics and scientific method. Then we're going to talk about the point which is measurement. And so this is one point, and here one point, and these ones details of it. And also we're going to talk about this third point. Okay, physics. What is physics? Physics is a science that studies mainly matter and energy and the relationship between them. Okay, in scientific method that we use in researches or to make experiments, we need to know main points in it. There is a word that is hypothesis and also experiment and law and theory. What is hypothesis? Hypothesis is like a guess or prediction for what's going to happen. For example, here, if I have a scale, I have here a scale, and I have a name, I have a person, his name is Muhammad. And I guess Muhammad's mass is 65 kilograms. I guess this is now prediction or guess. Maybe this prediction will be true, maybe will be false. So that means this guess now, or this hypothesis, it has to be tested by what? By experiment to show that it's gonna be true or false. So when Muhammad now weighs his mass on this scale, if it becomes 65, that means this guess or this hypothesis is true. If not, that means it's not true. So this is what is hypothesis is. So hypothesis, it needs to be tested by experiment to show that if it's true or not true. So we understand now what is hypothesis and we understand what is experiment, right? Okay, we go to the next point, which is law. What is law here in this case? Law in science, it goes after many, if you make experiments and you repeat the experiments too many times, you will go to a conclusion. This conclusion now you can restate it as law. So law, it shows how things or how things are going, but it doesn't explain why it goes. For example, this example, which is force equals mass times acceleration. This is a law. And this law now, it comes after many experiments. Also here, the weight equals what? Mass times gravity. This law now, it came after many experiments that it showed it is true. So that means this one now is law, and it can be written as mathematical formula. But it doesn't tell you why. It doesn't explain why this one here, why the weight equals like this one here. It doesn't explain why. It says, or it's a statement. It shows what is there after many experiments. Okay, for example, another example for law, when I say energy is neither destroyed nor created. This is now another law. But does it explain why? Why does that happen? No, just it gives you a statement after many experiments that proved it's right, but it doesn't explain why. Okay, theory, it's an explanation of why that things happen. So if you have many experiments, many things, and you have many details, and they are scientific data that you got them after experiments and surveys and observations, you get these ones. Now you're going to explain how something happens and explains why something happens. This one, it becomes what? Theory. So mainly it is what? Explanation. So we finished now the first point, which is scientific method, or the words that are related to them. Okay, we go now to the next point, which is measurement. Okay, in this point now, what is measurement? Measurement, mainly, it's to compare unknown quantity to known quantity. For example, now, we know that, for example, here, this length is 1 meter as a unit of distance or length. This one now, this length, SI unit is 1 meter. So we know exactly how the length of 1 meter. Okay, when we go to measure now the distance of this length, and if we find it, for example, now 3 meters, it means we are comparing this distance compared to this standard one. So this is now as a standard. 1 meter is standard. 1 kilometer is standard. So these ones are standard, right? So we are comparing this unknown quantity, which is here, and we found it's 3 times this one. So we are comparing it to the standard, and we found it is 3 times the standard quantity. So also for kilograms, when you say my mass is 65 kilograms, that means now you are comparing yourself or your mass compared to a standard mass, which is 1 kilogram, that we agreed on it, that this mass now represents or is called 1 kilogram. So if you compare now your mass to that kilogram, you're going to find yourself 65 times that standard one. So this is now what measurement is. Okay, now to measure things, we need scales, we need instruments. So these instruments now, they need to be precise. They need to be precise. How precise an instrument is. So an instrument is, for example, as a ruler. If I want to get the ruler here, I want to get the length of this distance. For example, now I found it 10.5 centimeter, for example. As you see, it has, by the way, it has here divisions for centimeters. And also it has small divisions for millimeters. How an instrument is precise? We agreed that the precision of an instrument, it is indicated by half its smallest division. So if the smallest division here is 1 millimeter, so that means half of this one now, it's gonna be or it indicates the precision of what? Of this instrument. So that means maybe this length now, it's gonna be plus or minus. So that means you have an error, and that error is about half the smallest division of that instrument. For example, now if I have a ruler and its smallest division is 3 or 4 millimeter, what is its precision? In this case, it's going to be half of this smallest division, so half the 4, it's going to be 2. Okay, next point now, what is an instrument adjustment? For example, now, I have scale. I have a scale. This scale now, if I put mass on it, it will give me a value, it will give me a number to express that mass as a number in terms of kilograms, for example. Okay, how I know this reading of this scale is right or not right? How do I know? So I need to make what? An instrument adjustment. What is a good way to adjust this instrument? It's called 2 points calibration. It's called what? 2 points calibration. Okay, what is 2 points calibration? So for example, now, if you put something on it and it gives you reading 30 kilograms, maybe this 30 kilograms is true, maybe it's not true. That means maybe it's exactly the actual mass of that object in it, maybe it's not. So in this case now, I need to adjust this instrument to make sure that it gives me accurate and right readings. So what I do now, I make 2 points. So first point here, I take a mass that is, for example, 5 kilograms, and I know it. So this is known quantity. It is 5 kilograms. And I put it here, and I make sure it gives me also what? 5 kilograms. Okay, now I made sure here for the first point, it gives me right readings. And I take another point. So this now, it means 1 point. Now I take another point. For example, I take another one, which is 30 kilograms. So this 30 grams, when I put it here on the scale, and when it gives me now 30 kilograms, that means now I made sure that instrument is adjusted. So that means now we are able to use it correctly. So how can you find the instrument adjustments? One of the best ways is to use 2 points calibration. This is just for the scale, and you can use it for any other instrument to make sure it's adjusted in the right way. Okay, Last point, we're going to talk about it here. It is accuracy and precision. What is accuracy and what is precision? I'm going to explain them with an example. For example, now I have a scale. I have a scale. And I want to know if this scale is accurate or precise, or both of them, or none of them. How do I know that this scale is precise or accurate, or both of them, or none of them? Okay, for example, now, if a person, his mass is 65 kilograms, and we know that this mass or the mass of this person is 65 kilograms. Okay, if we put the mass here, we're going to repeat it many times. For example, to make sure it gives me right or good values. Here, for example, now, if you put it for the first time, it will give me, for example, 64.95. Okay, then we put it another time. It gave me here 65.15. Okay, then we made it a third time. It gives me, for example, here a value that is 64.98. So as you see now, these values, are they close to the actual value? So the actual value is 65, and this scale now, for this mass, it gave me the first reading like this, second reading, third reading. So these values now, or these readings now, they are close to what? They are close to the actual value. So if they are close to the actual value, so in this case, we say, this one is what? Is accurate. This one is accurate. So this scale now is accurate. Okay, now how we know if it is precise or no? Okay, if it gives me, for example, values like 90 or 59.3, then it gives me another value like 59.4. Then it gives me another value like, for example, 60.1. So in this case now, as you see, these values are close to each other, but they are not close to the actual value. So as long as these values are close to each other, regardless whether they are close to the actual value or not, we say this instrument is what, or this is device. This device is what? Precise. So precise means that the numbers or the readings are close to each other, regardless whether is it close to the actual or no. So we say this instrument is precise. But sometimes you find them both. Like here now, if you go back to see these ones now, you're going to see that these numbers, they are close to each other, as you see, and also they are close to the actual value. So that means in this case, we say it is actual and also what? Precise. So accurate and precise means when the readings are close to each other, we call it precise. And when they are close also to the actual value, we say it is what? It is accurate. Sometimes if it gives me reading, like for example, 39, and it gives me another reading like 53, like 41. So as you see these ones now, these readings are not close to each other. So since they are not close to each other, so that means they are not precise. Number two, are they close to the actual value, which is 65? No, they are not. So that means it's not accurate. So sometimes a device can be accurate and precise. Sometimes it's precise only. Sometimes it's neither precise nor accurate. Thank you so much. This is for this part.